Know your IS code provisions short lecture series. So in this short lecture, I will explain about out of plane offsets. So this out of plane offset is one of the plan irregularities. When it is present, structure will have a discontinued load path, and also it leads to stability issues. So let's look at what are the code provisions to safeguard against out of plane offsets. Yeah, that is table number 5, plan irregularities, out of plane offset. What code says is out of plane offsets in vertical elements resisting lateral loads cause discontinuities and detours in the load path, which is known to be detrimental to the earthquake safety of the building. So how it will look like? Now, a building is said to have out of plane offset in vertical elements when structural walls or frames are moved out of plane in any story along the height of the building. Something like this, you can see. So this is vertical resisting element, first one, second vertical resisting element, third vertical resisting element. So this is fourth vertical resisting element, but this is not continuing till the bottom. So it is offset to inner frame, and going down here. So this is the out of plane offset. Now out of plane offset leads to discontinuity. So that means there is non-availability of primary load path. So earthquake force is the inertia force. This is induced inertia force. From diaphragm level, it is fed to vertical resisting elements. From there, it is always advisable to go for a direct load path. So in its own plane. So when this out of plane offset is there, it leads to indirect load path, and that leads to stability issues. So let me show that in detail. Let's look at this case. So this is plan, and where many frames are there, say 1, 2, 3, 4, 5, 6, 7. 7 frames in Y direction are there, and then 2 structural walls are there, 2 structural walls. This is in ground floor. In upper floors, so this left side structural wall is continuing till the top, but the right side structural wall is having an offset. So that means, so at the base, whatever structural wall is there, while going up, so that is shifted. So that means from top, it has come up to ground floor, and then at ground floor, it has shifted. So this is structural walls in all upper floors. So this is in plane discontinuity. Now let's look at out of plane discontinuity, how it looks like. So again, base is same. So 2 structural walls are there at the edges, left side and right side. This is at the ground floor, structural wall at the ground floor. And then you can see here, so this structural wall is offset. So not in plane, this is out of plane. So in the earlier case, it is in plane. So in this case, it is out of plane offset. Now this is in upper floors. So like say, suppose a 10-story structure is there. So from 2nd story up to 10th story, structural wall is there in this grid, but in ground floor, it has shifted. So to the outer grid. So this is out of plane offset. So out of plane discontinuity. Now, because of this one, huge demand will be there on the lower story columns and also the connecting elements. Now let's look at what are the code provisions to safeguard against this condition. Now in a building with out of plane offsets in vertical elements, what code says is, first, if it is there in zone 2, specialist literature shall be referred for the design of such building. Then if it is in zone 3, zone 4 and zone 5, so that means what out of plane offset is there in zone 3, zone 4 and zone 5, then what code says is, so we have to meet the 2 conditions. Condition number 1 is forces and moments due to earthquake effects in the elements connecting 2 vertical elements with, with out of plane offset elements. The vertical element supporting the offset and connection shall be enhanced by factor of at least 2.5. So look at this carefully. The forces and moments due to earthquake effects in elements connecting the two vertical elements, with out of plane offset elements. That means what? You can see this is one vertical element, this is another vertical element. So this horizontal beam, okay, this horizontal beam or this horizontal this horizontal element has to be designed for 2.5 times the load which is coming from the analysis, and also the vertical element supporting the offset. So that means what? This base and this horizontal, so these two elements. So this one, the circle. So this the below columns, below vertical resisting element, and this horizontal element. So these two elements have to be designed for 2.5 times factored compared to whatever has come from the analysis. Then another condition is lateral drift of this floor shall be restricted to 0.2% and all the stories below that. So these are the two conditions. So again, the forces and moments due to earthquake effects in the elements connecting two vertical elements, that is this from here to here and then from here to here. So these are the two vertical elements. This is a connecting element. So this connecting element as well as this element which is supporting has to be designed for 2.5 times the force, which is, that is forces and moments, and also the lateral drift is restricted to 0.2%. So the idea of this lecture is to help students and practicing engineers to understand the IS code provisions in a better manner. So following references have been used, and I sincerely acknowledge the help of my students in preparation of this lecture. Thank you.